All right, so in our last couple of videos, we've been looking at how to solve a system of equations by graphing. And one of the things that we have found as we looked at some of those problems, and perhaps as you work through some of the practice problems on your own, I think one of the things that we found is that while it makes sense to look for the place where lines are crossing by graphing them to see where they actually physically are crossing, the problem is that the numbers don't always work out nicely. And you have to deal with all kinds of difficulties like numbers that cause your graph to get really big, or dealing with how do you find fractions, or just there's all kinds of issues. And so fortunately, while graphing is very intuitive, it's not always the easiest, and there are other methods. I guess that's the fortunately part. There are other methods, okay? So that's what we're gonna start looking at in this video. In this video, what we're gonna do is we're gonna introduce a concept called solving with substitution. So that's the next method that we'll look at. And there will be another video with examples of substitution too. And then we will also later on look at a third method. In another video, we'll look at a third method called elimination. So those are gonna be the three methods that we're gonna learn: graphing, substitution, and elimination. And this video is on substitution. So with that said, let's take a look at our learning objective. There's only one: be able to solve using substitution. That's our only objective. All right, so in one of the previous videos on graphing, we looked at this problem right here. And we talked about how to solve this problem using a graph. And this one actually turns out to solve fairly nicely. There's nothing wrong with solving this with a graph. Of course, you have to get the y by itself, probably, if you're going to use the technique of intercept and slope to make that graph. There are other techniques, but that's probably what most of us would do. So there's a little bit of work, but it's very manageable. Well, what the technique of substitution does is it borrows from another math concept that you've learned previously, probably going all the way back to your pre-algebra class or even earlier. And the way that substitution works, we know, is if we have two things, which we have right here, that are equal, right? Math, the equal sign in math is the same as saying that they're the same, right? X is the same as 3, 3 is the same as X. They're equal to each other, they're equivalent to each other. It's a fair trade if I give you X's and you give me 3's, or vice versa. Okay, that's the idea of equality. And then the idea of substitution says, well, if they're the same, if they're equivalent, if there's no difference between a 3 and an X, then up here where there's an X, it's legal for me to say, hey, X's are the same as 3's, and so I can swap those two things out. I can make a trade and take the X's that are there and replace those X's with the 3 that they're equivalent to. And this is something at its basic level that you've done before. So if I take these two equations and use the concept of substitution, the top equation can be replaced with a 2 not times X, but with a 2 times 3. And then I have something that only has one variable. It only has a y. That's what makes this thing hard to figure out what's going on with, is that we have two variables. But now I only have one variable. So if I simplify this, 2 times 3, well, that's equal to 6. And then if I subtract 6 from both sides, I'll have that the opposite of y is equal to -3. And so therefore, the opposite of both sides, y is equal to +3. Okay, so that's a pretty easy, handy way to figure out y. And remember, we already know what X is. So if we know what X is, and we know what y is, then we can take those two pieces of information, put them into an ordered pair, and suddenly I have a solution to this problem, just like this. Now, we didn't draw a graph or anything, but remember, what this is telling me is where the two graphs would cross, where the intersection of those two lines would be. What's the point that those two lines have in common? That's what this is telling me, and I didn't have to make a graph at all. Okay, so that is very, very helpful, very, very handy, especially in problems where graphing isn't convenient. we can simply make trades. If we know two things are equal, we make a replacement. And boom, we can get to an answer. So this is the basic idea of substitution. And it's a basic idea that you've done before. I do kind of feel a little bit like maybe it would be worth our time to verify by looking at a graph that 3, 3 actually is the answer. So before we move on to taking this to a new level, let's do that. And I think we can do it fairly quickly because we've practiced this before. Okay, so up here, if I get the y by itself, and this work is in a previous video, so I'm going to go kind of fast here. I'm not going to really take a lot of time to do this. I just want to verify that we know that this works out well. So if you go back to a previous video, you can check this work and make sure that you agree with it. But I think if we get y by itself up here, this is the equation that we would get. And of course, x equals 3, that's the same equation. If I'm graphing this, then x equals 3 is going to be over 3 units and then straight up and down. So there's my x equals 3. Okay. And then 1, 2, 3, 1, 2, 3. So this has a y-intercept of 3, a slope of 2, so up 2 over 1, up 2 over 1, up 2 over 1. And sure enough, we can see right there that where this is going to cross is at the point 3, 3, which is exactly what we found. So this solution that we can find by graphing, I can also find it by just simply doing algebra. And when the problem ends up giving you numbers that are not nice, this technique usually works out to be a little easier. Okay, so this is the basic idea. We can do this exact same work just simply through algebra. So with that said, now, one last thing that I want to say before we move into building this all the way out is notice that it is a little more abstract. You have to remember that when you find this, what you're finding is this, right? That's something that now it's not obvious looking at this that what you just found is the point that the two lines have in common. Here it's obvious, here it's not. Okay, so that's the idea that the algebra methods are more abstract. They often work out to be more just nicer work, but it's a more abstract practice. So it's on you as the mathematician to make sure that you understand what's going on. Okay, so that's our basic idea. That's our basic idea. But not every problem is quite as simple as that. So let's take another problem. Let's say I have x minus y is equal to 3. And let's say x plus 2y is equal to 15. Okay, so there's my next system of equations. There's my next system of equations. And we're going to solve this. So I guess technically we might say this is example 2. If we would call that last one that we just looked at example 1, then this would be example 2. So we're going to solve that system of equations. Okay, and we're going to use the technique of substitution. Now you might recognize right off the bat there's a problem. In this method, we already knew what x was. We knew what x was, so we could just plug it right in and life was good and wonderful. Okay, in this problem, we don't know what x or what y is. Okay, but we can still do this method. We can kind of force this method to still work. What we have to do is we have to kind of ratchet things up one notch. We have to make it a little bit more involved, but we can still do this. Here's how we can do this. What you're going to do is pick one equation, and truthfully, it doesn't matter which. In this problem, I'm going to pick the one on top. And in that one equation, you're going to choose to get one of the variables by itself. Again, it doesn't really matter which. I'm just going to choose to get the x by itself. Okay, now the reason I'm choosing x for right now, let's just say it's because I like x's better than y's. That's not true, but let's just say that for now, because it's completely arbitrary. It's totally up to you as the mathematician. It does not matter which variable you get by itself. Okay, I'm going to choose to get x by itself. And notice what happened when I did that. When I took this equation and I got the x by itself, now I know something that is the same as x. Okay, those things are the same. Now, I don't know exactly what x is, but whatever it is, it's the same as y plus 3. So it's not quite as convenient as the last problem where I knew a number for x, but I do know something about x that will let me make trades. So here's what I can do. I have an equation here that has x's and it has y's. I can't solve an equation that has two variables. But this equation tells me the relationship between x and y, that x is the same as y plus 3. So I can make a trade. I can make a swap. If these things are equivalent, then there's nothing wrong with saying, hey, look, this equation has an x. X is the same as y plus 3. So let's take out that x and trade it for y plus 3, because that's a fair trade. And then the rest of the equation doesn't change. It stays the same. So now all of a sudden, just like we saw in example number 1, now all of a sudden I have an equation that only has one variable in it. It only has y's. Now it does have two y's, but there's only one kind of variable. And since there's only one kind of variable, I can solve that. So the first thing I want to do is get rid of my parentheses. Well, in this case, there's nothing to do to my parentheses. I mean, I guess if you want to think of a ninja 1 hiding out here that you're going to distribute, but when you multiply by 1, nothing happens. So those parentheses I can really just ignore. And then I want to simplify this over here by combining like terms. So if I have 1y and somebody gives me 2 more y's, I'm going to have 3 y's all together. And that 3 doesn't combine with anything yet. So now I've got everything nicely simplified. Now I want to get y by itself. So the first thing I would do is subtract 3 from both sides of my equation. That leaves me with a 3y equal to 12. And now I can divide both sides by 3. That leaves me with a y equal to 4. Okay, so now we know what y is. That's fantastic. We still haven't solved the problem because we still don't know the point where they cross, because we still don't know the x value. But we're closer. We know what y is. And don't forget, we also know the relationship between x and y. So now I can take this, that I know what y is. I can take this relationship that I found earlier, and I can combine those together to say x is the same as y plus 3, and y is the same as 4. So I can make that trade. And now I can figure out what x is. X has to be 7. X has to be 7. And so I have found my solution. The solution is the point where x is equal to 7 and y is equal to 4. And there's my solution. Now, just like we did before, we can check that by going back to our original problem and plugging these numbers in. So if I plug in a 7 and a 4 here, is 7 minus 4 equal to 3? Well, yes, it is. So that works. And if I plug in a 7 and a 4 here, 4 times 2 would be 8. 7 plus 8 is equal to 15. So it works. Okay, so this is our basic idea of using substitution. In fact, some people might say we're using repeated substitution, because first we substitute into one equation, do a bunch of work, and then we substitute into another equation to get our answer. So some people might call this repeated substitution or double substitution, but that's the method of substitution. Let's outline those basic steps, and then we'll call it good enough on this video. Like I said at the beginning, I am going to put another video together that has lots of examples in it. But for this video, outlining the basic idea, here's the crux of the matter. Steps for solving a system by substitution. Okay, steps for solving a system by substitution. The first step that we did was we picked one equation and get one variable in that equation all by itself. Okay, And it doesn't matter which equation or which variable you do. You can't pick the wrong variable. It's your choice. You can't pick the wrong variable. Now, you can make a mistake in getting it all by itself, but you can't pick the wrong variable, okay? So that's what we did right here. This was our step number 1, right? This work here. We picked one equation, we picked one variable, and we got that variable by itself. There's our step number 1, okay? Step number 2. Now, it's your choice. You can pick any variable you want. There will be problems where one option is easier than the other. Consider this first example that we looked at the very, very beginning. Obviously, this is the one I'm going to pick because it's already done, right? It would be silly to pick the other one. This one is already done. So on this problem, I probably wouldn't want to get this y by itself because there would be a lot of work. I'd have to move the x, I'd have to divide by 2. So there are variables that are easier and there are variables that are harder, but there's never a variable that's wrong. So step number 1, it doesn't matter which one you choose. If one looks like it's easier to you, then that's the one you should choose. And if they all look like they would be equally difficult, then it doesn't matter, just pick one and do it, okay? So that's our first step, step number 1. Now, on step number 2, you don't get a choice. On step number 2, what you have to do is substitute your answer from step number 1. So up here in step number 1, we're getting one of the variables by itself. Whatever we find that variable is, we're going to substitute that thing. That's our answer from step number 1. We're going to substitute that thing into the other equation. Whoops, equation has a U in it, doesn't it? Equation, there we go. Into the other equation, okay? For this one, there's no choice. You must use your answer from step 1, and you must put it into the other equation. There's no choice here. So this is where you get your choice. Here, there's no option. You've got to do that. Okay. Once you do that, don't forget, I'm going to just make this off to the side as a reminder. Okay. Don't forget, we've been saying it all year long. When you do substitution, use parentheses. Don't forget to use parentheses, okay? We'll always use parentheses when we do substitution. All right, so once you've plugged that in, now we're going to solve for the remaining variable. Solve for the remaining variable. Let's look at the example we just did to make sure we understand what that means, okay? So here was our step number 1. We got one of the variables by itself. Here's our step number 2. We took the answer from step number 1 and we substitute it into the other equation. That's our step number 2. We made sure we used parentheses when we did that, okay? So that's our step number 2. In the other equation, not the one that we solved, the other equation, we took our answer and we plugged that in. There's our step number 2. Now, step number 3, notice once we did that, there was only one variable left. So we solved for that variable, okay? Now, this takes us back to things that we've learned early in our class. When we solve something like this, first we're going to need to simplify and things like that, but the bottom line is we solved, okay? There were several steps to do it, but eventually we knew that y was equal to 4, all right? So that's our step number 3 right here. This is our step number 3. So from here to here, that's all step number 3, and there's our answer from step number 3. Okay. Now, once we do that, number 4, take that answer. This is your second substitution. So that's why I say some people would call this double substitution or repeated substitution. Substitute your answer from step number 3. Substitute your answer from step number 3 into your answer from step number 1. Okay, substitute your answer from step number 3 into your answer from step number 1. Again, let's look at the example we just did to make sure we understand what that means. So once we got y all by itself and we knew that y was equal to 4, that was our answer from step number 3. Back up here, step number 1 was when we got x by itself. So this was our answer from step number 1. And notice, because the x is by itself, now I have an equation that's really easy to plug numbers into. And so that's why we take our answer from step 1 and our answer from step 3. We put those two answers together, and there's our answer from step number 4 right there. That's our answer from step number 4. Okay, so we substitute into there and simplify. Substitute and simplify right there. Okay, substitute and simplify. And then we're done. Every good mathematician likes to end their process by checking their answer. Whoops, checking does not have an R. Check your answer. Okay, so check your answer when you're done. However, I will say that when it comes to solving by substitution, checking your answer is a little bit less important than it was with graphing. In graphing, it was important because if your graph was a little bit off, you could end up with something that looks like a right answer, but is actually very wrong. In substitution, as long as you don't make any mistakes in your algebra, you're not going to get a wrong answer. So really, this check step is really based on how confident are you in your algebra. If you're very confident, you can skip this step and get away with it. But if you make a mistake anywhere in this process, checking your answer would help you to find that mistake. Okay, so that is our basic process. And as I said, for this video, we're going to stop here because we've done everything we need to do to make sure that we know how to solve a system of equations using substitution, which was our learning objective. These are the 5 steps to achieve that. Okay, like I said, I will put together another video that has examples, but there's our basic process. Thanks for watching. Have a good one.